All right, so let's get started. So thank you all for joining. We will talk a little bit about in the next 40 minutes how you can use like other languages like Python, JavaScript, Ruby, or WebAssembly, or even C inside of Java by using GraalVM. So who am I? My name is Christian. I've been working as a software engineer for the last 15 years now. I am a Microsoft MVP for web development and Oracle ACE in Java. And you can find all the code I will show you today on my website, type.rocks. You can also find there my LinkedIn. So if you have questions after the talk, just send me a message there or ask me after outside. So what is GraalVM like on a higher level? Basically, it's made out of 3 parts. The first one is it's a normal JDK. Like you can use it like you would use an Open JDK or an Eclipse Tamarine. Anything you can just exchange it and can use as normal JDK. But what it also is, it also supports really high performance, even in JIT mode. So because it was developed quite recently, like in the last 5 to 10 years, it does some really important performance. It has some really important performance advantages. Also, and this is something which is only available in Graal, it has so-called ahead-of-time compilation. Now, certain parts of that are now also in the JDK, in the normal one, but what it supports is so-called native ahead-of-time compilation. This means you can pack your Java application into a native binary, which then has a much lower memory footprint. For example, you can say you want to build it for Linux or for Windows and so on. And of course, Java normally is for like build once, run everywhere, but often it's just the case you run it like on your Linux server, so you don't have to have all these libraries in there for other operating systems. But what it's also like, and I think this is something which is often overseen, is that it supports polyglot programming languages. So it can be a host for many different programming languages. And we will focus about these polyglot languages right now because I think this is something which we as a developer often need, and sometimes this is like the pain point we have in our daily business. So let's show a real use case. Let's say we have this landscape here, and we have team A. We are in team A. We have a Spring Boot application. Now, let's say we have another team which created a validation library in JavaScript. It's like the front-end team, and they use it to have to validate personal information which the user sends to see if it's correctly shaped, and if not, it like throws an error. And there is also another team which does has created a graph library which shows certain results with a certain theme. So they use, for example, Pygol from Python. Now the issue is when we as a team decide that we want to use these libraries, it's not really possible to do that without having like some additional architecture. So for example, what we would need to do is we would need to have like an express REST endpoint available to access this JavaScript code, and for example, Django for Python or any other REST framework which allows us to access it over HTTP or using like protobuf or any other protocol. Now, the issue is not that this isn't possible. Of course, you could do that. But the main issue is, first, we need to add additional code because most likely these other 2 teams have not provided that if they are only using it like internally. And the second thing is also that we are dependent on other teams. Let's say we want to use this, but the other teams are also really busy building stuff. Then we can't just tell them, yeah, you need to provide this for us if like the pressure is not high enough like from the business perspective. So wouldn't it be nicer if we had it like this? If we have our Spring Boot application, and inside we have our validation library, which we can use like we would with a Maven dependency, or the same with the graph library. So when we could just say we add this Maven dependency of this library and we can use it inside of Java. Now, why is this much nicer? First, in my opinion, a library is always easier to use than like a REST service because first, you don't have any additional HTTP calls. You also don't need to serialize and deserialize your stuff. You always have like these fixed APIs. For example, you can always be sure that if I don't update to a new version, then I can always be sure that the API will not change. When we have an HTTP or a REST endpoint, the schema always could change. If they update their code, we also have to change, otherwise we will like break in production. So we create like this dependency on each other. If one changes something, the other one needs to update. Also, we don't need any boilerplate code, so we don't need to update to add additional layers of abstraction on top of this library just to use it. And I think this is the most important thing, the teams can do this internally. We are not dependent on other teams, and this also means we can do this like during a sprint, and we don't have to wait until the other team is ready to do this stuff. So what is the architecture of Polyglot? It's quite simple. We can see here at the bottom we have the JVM, so the Java Hotspot VM, and this is just the thing which runs your Java code. Now on top of that we can see we have this GraalVM compiler. Now what is this? This is just the replacement for the normal JDK, like which converts your Java or Kotlin code into JVM bytecode. Now the additional thing, which is specific to the GraalVM, is on top here with the language implementation framework. And this is called Truffle, and what this simply allows is you can take a language, for example JavaScript, and you create an implementation for it with the Truffle framework, and this will just convert this JavaScript or Ruby or Python code into an abstract syntax tree representation, which then can be read by the GraalVM compiler. So, for example, JavaScript and Python are developed by Oracle, but also are open source. And Ruby, for example, is a community project. So, if you have like your own language which isn't shown here, you could also implement that yourself. So, this is an image from Oracle, of course, and they want you to use it with their JDK, of course. But what's really nice is that you don't have to use the GraalVM JDK to run your GraalVM Polyglot applications. You can use any JDK, and we will see this in a second. And inside of these GraalVM JavaScript and Python parts, this will then use the GraalVM compiler. But you don't have to switch to another JDK just so that you can use this. So we will talk about two of these polyglot languages today, about GraalJS and GraalPy. And the important thing is, first, of course, they are open source, so you can just go to GitHub and see what's developed. There are also community versions of these, so you can use one which is completely done by the community if you don't like to work with the Oracle licensing model. Also, they don't have any dependencies. You can just drop them into your Maven project, and as mentioned, compatible with every JDK, so you don't have to switch your JDK. But of course, they are the fastest when you use them with the GraalVM JDK, because then the compiler is the same over the whole stack, and they can do some really nice performance optimizations. Now, to see some benchmarks here for Python, for example, we can see here that for GraalPy with version 23, this is like up to 4 times faster than using the CPython by using this benchmark, the geomean speedup. We can see the geomean speedup over CPython is about like 4 times. And also with Jython, which can also be used to run Python in Java, it's also much faster. Now, of course, what you always have to think about is that Python code is often just glue code between, like, for C. So this means, like, the C code, of course, is not touched. So if you have something which just calls into C libraries, it doesn't really matter. For JavaScript, we had for a long time the Nashorn scripting language. This is now no longer available in Java, so if you want to call JavaScript, you have to use another tool. And we can see here that for the Nashorn scripting engine, it took, like, for this benchmark 800 milliseconds, and for the other ones, like for GraalJS Polyglot or the script engine, which is used in Polyglot, is like 150 milliseconds, so quite faster. But let's now switch over into some code, and let's develop this application we have seen here. So we have a Spring Boot application as a wrapper, and inside we will then call into JavaScript and into Python. So for that, let's switch over. And we're here in a simple Spring Boot application. And to get started, let's go into our POM.xml. And we can see here this isn't a huge file. It's just containing some information about the GraalVM version and the Maven version and the Java version. I'm using 25. And we can see here the interesting part starts here. We have our Python community version and our JavaScript community version. You can also use the one without the community suffix if you want to use the highly optimized one from Oracle, but this also works perfectly fine. Now, the only thing which is a little bit special is we have these Python embeddings, because this makes it easier to package the Python packages inside of your jar, which will then get created. Another cool thing is we have this GraalVM Maven plugin where we can specify where do we want to store our packages which get installed, and we then can say which of them we want to install. I have here Pygol in version 3 and setup tools just to be able to start the application. So by using just this plugin here, we are sure that this is now available when we are using it in our Python code. So let's now switch over and let me show you how this library looks like. And we can see here I also have a package.json file which has a dependency here of sort. Sort is just a simple schema validation library, and we will see in a second how this works when I open my library file here. Now, of course, this could be much, much larger, but this is just like a really simple example how this works. So we can see here we have this person schema, and we say this is an object, so this schema has to be an object with a first name and a last name, and it has to be a string with a min length of 3 and max length of 20. Then what we can do is we just export here any function, and we say we want to parse this JSON object, and if there are any errors, then we want to return them as an array, otherwise just return an empty array. Now, we will see in a second why I have written here that this has to be JSON, because this implies some wrapping we have to do. But let's now switch back again into our application, and let's create our REST controller. So let's go in here, and we will just say here, let's make this a little bit bigger, and we have a REST controller in here, and we have our REST request mapping here, where we say /API. And now we want to do a post mapping. So we have this post mapping here, and we want to have a validate endpoint. And for each call to this validate endpoint, what we want to have at the end is we want to call our JavaScript library with a person object and then return the result in Java to the user. So we will first say this is a list here of sort result, and we call this validate person, and we will send here a person, which is a request body. Oops, request body like this. Now, what is this sort result? This is just a simple record here, which is a wrapper around a code, because sort always returns back a code, for example, too small, too big, if something is not matching. So we also want to have this person here. What is this person? This is also a simple wrapper around a first name and a last name. Now, how can we now use our library? Now, what we could do, of course, is when we check this, we could, of course, just say, okay, we take our person, use an object mapper, convert it into JSON, and then put it and then call our JavaScript function here. But I don't really like that approach, because when using GraalVM, we have the opportunity to just pass around Java objects even into our JavaScript libraries. And for that, we have to write a small wrapper. So this is something which we only have to do because this is like a complex object. If you would put in like a string or numbers or even maps, then you don't have to do this, but because this is like a complex person, we have to do that. So let's think of this lib.mjs file as being something from another team, which you just can use with npm install. So what we now will do is we'll just create a new wrapper.mjs file. And now let's import this validate function. And let's now say we have a validate person function here, and this is person Java object. Now, what we do in here is we have our results, and we call validate. And now we have to think of what we need to do in here, because we will call this validate person function from Java, and we will pass it our Java person object. So we need to map these into our JavaScript, in our JSON object. So what we'll do here is we have our first name, and we call person Java object.firstname, and we have our last name, and we call person Java object.lastname. Now, we are here in JavaScript, but we can still access the same syntax as we would with normal Java records, because at the end, this will get executed in Java. So now we have the results, and what we now want to do is we want to return them as a list of sort results. So what we can do here is we say results.map, and we have our result, and we want to do something like this. We want to have our sort result, result.code, because our validate function will return a list of which has a code in there. Now, you may be thinking, well, how can I access this sort result here? Because this sort result is just a Java class, right? But at the end, because this JavaScript code will get converted in an abstract syntax tree and then used in Java, we can do this. We can just say, we create a new result variable here, and we call java.type, and we pass it the path, the package path, to our Java class. And now we can use Java stuff inside of JavaScript here. So we could even say we want to have the list interface, and we can use java.type and can then access it like that. So we can access all the Java stuff inside of JavaScript. Of course, not only in JavaScript, also in Python, Ruby, files, and so on. Now that we have done this, we are already done with this wrapper, and let's now use this wrapper inside of our main controller. So for that, let's open the main controller again. And I will create a small wrapper for this. So of course we could use like constructor injection, but I will use it like this. I will have a GraalJS service, and like that. And we will create this. Now, what will this GraalJS service do? We have the service here, and what we need to have is a so-called context. Now, the context is defining in GraalVM what we want to load from JavaScript or from other libraries, and this is like a sandboxed environment. So what we have, let's go back here into our wrapper. So what this wrapper is, as you can see, this is just one file which has a function we export called validatePerson. So we want to make this available in Java. So to achieve this, let's go into the GraalJS service, and let's first create a functional interface. Now let's call this functional interface validateWrapper. And of course, we could just work with normal function lambdas from Java, but the issue is that this isn't really nice to call because you then always have to use like apply, and it's not really nice to work with that. So what I always like to do is I always like to create such a functional interface wrapper, because I can then say this returns a list of SOT results, and we call this validatePerson, and this will pass in a person like that. Now let's create this private validate wrapper here. And now we can use like a post construct. Of course, there are other ways to do that. I will use it like that. And we will create this context. Now the context here, we take from GraalVM Polyglot, and we use a new builder. And here you can define what kind of languages you want to allow in this specific context. Here I'm using JavaScript and Python. And now we can also do really nicely check what kind of access you want to allow. We can, for example, say, is it allowed to create a process? What kind of classes are allowed to be called? So we don't like give it access to everything in Java. We can really specify what we want. In my case, I don't really care for this case, so I use allow all access. And I also say I want to use allow experimental options so that I can do cool stuff with JavaScript. Now also, we will set two options. Because we want to use this export syntax to make the function available. So I will use it like this. And I will also say .option, and I will have my option.yes comment.js require, and also set this to true. And now we're already done and have the context. Now that we have built like our sandbox, we need to pass our source into this sandbox. So we say we have our source file, and we can use source from GraalVM Polyglot. And we also say we create a new builder. We say this file is a JavaScript file, and then we just say path of source main JavaScript wrapper.mjs, and put this into a file. And then we build it. Now, you can see here, I'm not putting in all the JavaScript files needed. We only have to put in the entry path, and everything else will then get resolved like you would do when you work with JavaScript normally. So now let's just say we throw this exception here. And now that we have the source, we can evaluate the source and put it into the context. So for that, I will have my validate wrapper, and they'll say equal context.eval, and I put my source in it. Now here you can see currently this does not work because this is a so-called value type. And this is because the GraalVM doesn't know what kind of result is in there. So we have to access the correct part of our file. So we can say here get member. And I will just say we have our validatePerson function in here. And then we cast this into our validateWrapper class. So to make sure that when we load this, this is in the correct shape. So of course, you could also say when this would not be like a simple function, but a class, you can also put in like a normal class, and this will then get converted into that. But in our case, it's just one simple function. Now that we have this validate wrapper, we can just expose this and we can say, well, I have this function in here which returns a list of SOT results, and let's call this validate person. I have my person in here, and I say return validate wrapper dot validate person with the person here. So this is everything we need to do in our GraalJS service. Now let's use this in our main controller here, and we just say return GraalJS service validate person, person like that. So let's now start the application, and let's see if this is working. So we can see here it already started. Let's now open our generated requests, and I will now send some data in there which is way too long. So let's do this, and we can see I get back the code for too big. So what happened is we got the request was passed into our the context was created on startup. When we call into it, then we will get back, and we will call into the JavaScript file, and this then returns the result. Now, something that just happened, but we didn't really think about, is when we check our wrapper.mjs, we can see here that this is just a list of SOT results, like a JavaScript list. But when we called this inside of our main controller, we can see we got back a Java list, a Java interface. Now, this is some mapping which happens automatically when we call into JavaScript and return it. The same also happens with Python. And so what we now will see is also how we can use Python, and using Python sometimes is even easier than using JavaScript and Java, because the types we have in Python are much easier to convert often than in JavaScript. So for that, let's go back here into our Python file here, in our libpy file, and we can see this is quite a simple file. We just have an import of our Pygol library, and we pass in here a dictionary and return a string. And for each of these key value pairs, we just add a new entry in our chart, and then we render it as an HTML. Now, you can see here we have this dictionary, and dictionaries get mapped into Java maps and vice versa. So we can just call it with a Java map, and this will then be will convert it into a Python dictionary. So for that to work, we don't need a wrapper, because we can just use it like that. So let's go back into the main controller, and let's just create another AutoWire class. So we have this AutoWired here, and let's call this private GraalPy service. And we have this GraalPy service like this, and let's create this class. And the first thing, of course, we do is, again, I create this functional interface. I call this interface PyWrapper, and we have our string which we return, and we call to Py, and in there we will pass a map, which has as the key will be a string, because this will be like the code we get back, and the value is long, like how often this appeared. So we have our dictionary in here, and now we do basically the same as in JavaScript. So we first say we have our variable here, our PyWrapper variable, and we have our post construct, and we do this after everything is done. Now, what we do what we don't do the same as with JavaScript, we don't use this context from GraalVM. Instead, we use this GraalPy resources context builder, because what this allows us to do is to pass our virtual file system path into it, and this makes it much easier than doing all this stuff manually. So we just say virtual file system new builder. And now, let me show you again in the pom.xml file, we have defined here that the resource directory is graalpy.vfs. So this means every package gets stored in there. So let's copy this, and let's use this in our GraalPy service. And we have our resource directory, and this is it. Now, we just need to call build, and we are ready with our Python context. So in here, we made sure that we can call Python, that we can load a Python class, a Python file, and that we now can evaluate it. So we have our source file here, and we call source new builder. We say this is of type Python, and we say again here path of source main Python, and we have our lib.py file, and then we just build it, and we throw the IO exception. Now, let's just evaluate it the same way we did before. We just assign PyWrapper here, and we say context.eval, and we call it on our source, and say, give me the member to Py, and we say this is a PyWrapper. Now, we just need to make sure that it's available outside. So we say, again, we create a function which returns a string, call this to_pi, and we pass in a string long map, and we have our dictionary in here, and we just say return PyWrapper.toPy and pass in our dictionary. And now we can just use this in our main controller. Now, to make sure that we have something to show, what we also need to do is we need to store the information, the validation information we get back when we call the validate endpoint so that we can show something. So for that, let's create a private static final map of string and long. And we have our database here where we store this. And we just say here we have our result. And we say if the result is empty, so if there are no errors happening, we just use db.merge, and we say for the key OK, we will increment this by 1. Otherwise, if it is not empty, we will just call result for each, and we have our entry we have here. Oops. We have our entry we have here, and we do the same, but of course not with the OK key, but with the error key we get back from our entry, like that. And after that, we just return again our result. So now let's just create our get mapping so that we have the result for our graph. So we have our /graph endpoint, and this will return a simple string and doesn't take any properties. And we just call return GraalPyService.toPy, and we pass in our database like this. So now let's restart the application, see if this is working. So as we can see, it is starting up. It's also loading the Python part here. And now let's go into our generated requests. And when we, again, send some data here, so for example, one which is too long, when we put this up here a little bit, we can see here this is too big. Let's say we have the normal last name. This will be an empty array. And when I now say I have too short of a last name, this will then be too small. And when I run this again, we get, again, the same result. Now let's switch into our browser. Oops. And we are now here on the API/graph path. And when I rerun this, we can see we get the result from our Python call. So we could call from Java into our JavaScript file to get the validation results, and then call our Python library and get back this HTML result. And of course, as you can see here, you can also do stuff with it. You have everything which is available in Pygal just rendered into HTML into your front end. Now, of course, this is just a really small part what you can do. The compatibility is quite good for GraalPy. For example, you can do also stuff like working with NumPy, working with Hugging Face if you want to work with AI. You can also use like PyTorch or Pandas for data processing. Normal Python packages are perfectly supported. Like there are some which aren't because they use like certain parts of Python which aren't supported by GraalVM yet. But you can check just, I will show you on the next slide the link to the page where you can see if your package is supported. But let's now go back again into IntelliJ, because something cool which we also can do is, when I go back into my GraalJS service, we can see here, I have said that in this context, I want to allow JavaScript and Python. So what this means is that in this context, I can run even JavaScript code in Python and Python code in JavaScript. So what I can do now, when I go into my wrapper MJS or libmjs, doesn't really matter, I can say here, polyglot.eval, and then I can say which language, and I can say print hello from Python. And when I now restart the application, we will see in a second that this will get printed into the console, and now we could call Python code from JavaScript, because at the end, the Java is just the host which converts all these different languages in JVM bytecode. So you can also call like Ruby code in JavaScript, JavaScript in other languages. So all these supported languages can now be called in each other. So even if you're not using Java and you still want, for example, use Python code in JavaScript, you could just run a host Java application which takes together all these different languages so that they can then talk with each other. So let's now go back into the PowerPoint. And what is there more to say currently? First thing is, what we could also do is, and I would really say you should do that, you can encapsulate these wrappers in their own library. And this is something maybe even the teams which develop these libraries, like Python, JavaScript libraries, are maybe willing to do, because as you can see, it's really small, and you can then use, for example, a Spring Boot starter and make it available for other teams. So for example, if you're a team who have a really nice library in JavaScript, Ruby, any other library, any other language, you can just create this wrapper and make it available so that any other Java team can use that. Also, these libraries are really easy testable. So this means like you can, of course, because they are just like used in normal Java and not over like an HTTP endpoint, you can also do integration tests without having to rely on that this service is available. For example, if you want to do some integration testing, if the calls are working correctly, you always have to make sure that the other team also has the service running. In this case, you don't have to. Also, you can do unit testing. You can just mock the whole service and makes it also really easy. The last thing I want to show you is also about exception handling being really nice. So let me switch again into IntelliJ here, and let's say at the start of the application an error happens. So I will just say throw new error, and I say unexpected things happened. And let's now see what happens when I restart the application, what kind of error I get. Because often we think, well, this maybe is like some code I don't understand where it's coming from. But we can see here, this is quite clear what happens. We can see we got a polyglot exception with the real error, and the stack trace is pointing at the exact line in the code where it happens. So it's not like a black box where you just say, yeah, somewhere in JavaScript this error happened. You can see in your Java stack trace that this happened, also from where you called it inside of your Java code. So it's really just, because it gets converted into JVM bytecode, you get proper stack traces. Now, also really cool, as mentioned, you have a great library compatibility, especially in Python and JavaScript. And also the licensing model is quite nice, even like for Oracle. You can go to this link and you can see they provide quite a huge amount of free stuff, so you don't have like to pay them to use this. Also, if you don't want to, there's also a community version. Now, there are really cool examples which you can look into when you go to github.com Oracle Graal. There are ones for every different language, and also, for example, because Ruby is no longer developed by Oracle themselves, they also have their own GitHub repository where you also can find really cool examples. So are there any questions? Yeah.
Hello, good morning. In your examples, all files, for instance, the JavaScript or the Python, were provided in advance. Can a user, let's say we have an application that a user is providing a new Python function or a new piece of code, can this be done dynamically? So let's say we have an application that the user can post a Python function or something and be executed on the fly. Or it should be available in a compilation time only?
No, really great question. No, of course you can do this. You can also, now I have loaded this source file, right? But you could also run this like inline, like doing just like basically what this, oops, not yet. So what this is doing here, this when I go into the Graal Py service or GraalJS service, we can see here, the thing I'm doing here is I just take this builder of an existing file, but what it basically does is it reads the string into it. So a user, of course, can just provide this on the fly. So you could just say, I have this function and run it. Of course, you have to you need to know what you are doing, but you can, because evil is always a little bit evil, but yeah. Are there other questions?
Hi, I just have a simple question that, so GraalVM is known for its really fast startup times. By using this polyglot framework, does it affect the startup time of GraalVM?
So, yeah, with GraalVM itself, it's really fast, and if you're using it, it shouldn't affect it beside the things which you need to load from Python, which are maybe dynamic, because like with GraalVM, you have always to make sure that the things are are before like clear what gets loaded, but you can see here, this is currently slow to get started because it's not using the GraalVM JDK. This would be much faster if it would. So of course, it will be a little bit slower because it needs to load certain stuff more, but it shouldn't really matter in most of the time.
Thank you.
Yeah.
Can I ask you, how does it work with the wrapper? Like, is there underneath some runtime, which is like for JavaScript, for example, Node.js? And what is the cost of doing the round trips between the JavaScript runtime and Java? And if it's feasible to validate this every time when you get a request at the backend for this Java, so all the time do the loop for the validation?
Yeah, that's really interesting because you mentioned Node. The important thing is that we have here this what is available, right? But don't get this wrong that it's calling Node. It's just a Node equivalent implementation from inside of Java, which can read this abstract syntax tree. And this is quite of course, it's not as fast as you would call it natively with Node because like they have to do some, because the implementation is maybe a little bit slower, but you can see maybe, for example, with Python, it's sometimes even faster. So the round trip is like almost non-existent because it's just normal Java code at the end, because you load the file once and it's not like compiling it every time or calling into JavaScript. So it should be really nothing to worry about, I think.
Got it, thank you.
There was oh, perfect, thank you. All right, yeah.
Is this faster than having the code of JavaScript, for example, in a separate container in a separate computer than in the same and doing the translation?
So I think it always depends a little bit, because if you are running this JavaScript stuff in its own container, then you always have to have these round trips of doing it like, of calling it with REST or with any other protocol, and you have to do serialization and deserialization. So in most cases, I think this is much faster doing it in there. There are certain cases where the runtime is better than the implementation from the GraalVM team. So then maybe if you have like really CPU intensive stuff, which is taking much more time than just these round trips, then maybe it's faster. But I think if you have something which you want to run in there, I will always try to do it first, like with, for example, with Graal. And if you really have performance issues, then I would see if you want to put it into its own container. Okay.
Thank you.
Any more questions? If not, I want to thank you, and I wish you an awesome rest of the conference. Thank you.